Hey guys, welcome back to the Pre-Calculus 20 videos. In this lesson, we're going to look at lesson 1 from chapter 3, which is all about quadratic equations in vertex form. So just as a quick recap, a quadratic function is an equation in which the highest exponent is 2. And when looking at the graph, it has the shape of a parabola or a U. So if we're going to go back and talk about this exponent with the highest power of 2, an example of that would be, say, y is equal to x squared plus 4x minus 2. So here we're looking at the exponent here, and it has a squared term, or it has an exponent of 2. So another example could, if we want to look at maybe one of the simplest quadratic functions, would be, say, y is equal to x squared. You could also have numbers in front of those variables, and that doesn't change whether or not these are quadratic values. So say you had negative 2x squared plus 4x. This here is still a quadratic equation because we still have that exponent as 2. If we were to look at the graph, essentially what would happen is that, I'm just going to do a quick rough sketch here, but so it could be opening up where your arrows are pointing in the upwards direction. We could also have one going down where those arrows are pointing down. So that's opening up in the downward direction. So we have a general equation for any quadratic equation in vertex form. And so that's one thing that's really going to be really important, is that we're going to come up with a few names throughout this whole chapter and give you different types of equations. And so the one they're going to look at is in vertex form. And so the general equation is y is equal to a times x minus p squared plus q. And so one thing that's really important about this equation is that it gives you the vertex, which is why it's called vertex form. And so your vertex is this p value and the q value. So your vertex would be at p and q. One thing that's really important to know is that in our equation we have x minus p. So say we were given the equation, we'd have to take the opposite value of what was in here. So say we had x minus 2, your p value would be the opposite, which is positive 2. If it were x plus 2, you'd have to take the opposite value, so your p value would be negative 2. Okay? So now let's go ahead and do an example, which is number 2 from your notes. So here we're going to determine a quadratic function in vertex form for the following graph. So in order to find or determine a quadratic function in vertex form, I always start off by writing our general equation for vertex form. So we have y is equal to a times x minus p squared plus q. So we can first start by finding p and q, and those are just your vertex. So your vertex is that little middle point in your graph that kind of creates a mirror line between the rest of your graph. So essentially what you want to do is you want to look for that maximum or minimum point. And in this case, our vertex is going to be right here because everything else kind of mirrors out after that. Okay, so you would kind of notice that there's a general trend in this graph, and if say you were to fold it in half right at that vertex, you would notice that you'd have the exact same graphs, and that they would overlap, say, on your paper if you were to fold it in half there. Okay, so it almost has this mirror line here. That's how you can tell where your vertex is. So our vertex here is at x is equal to 2 and y is equal to negative 3. So we have our vertex is 2 and negative 3. So then we can put this into our equation. So we have y is equal to a times x minus our p value. So remember, we have p and q, so we want this p value. Then that value is squared, and we're going to add our q value, or add negative 3. I'm just going to rewrite this just to clean it up. So we have y is equal to a times x minus 2 squared, and we know that a positive times a negative is just a negative. So far our equation is y is equal to a times x minus 2 squared minus 3. So to figure out our a value, this one here is not quite as simple as just simply looking at the graph. We actually need to do some calculations with this. So to find A, we need to choose a point from our graph and plug it into our equation. So we'll sub it into our equation. So when we choose our point, this here is going to find us an x value and a y value. So then the only variable that we're going to have left in our equation is this a value. So then what we'll do is we're going to solve for a. So I'm just going to scroll up and look at our graph here. So when you're choosing your points, you can really choose any point that's on your graph. But one thing that I would recommend is choose a nice point. Don't use one where you have to estimate the value, because then you could have an error. And then also don't choose ones that have really high values, because then that's just getting into complicated calculations where you have to do more work than might be absolutely necessary. So typically what I like to do is choose maybe a point on your x or y axis, because then you're at least one of those values is going to be 0, and it kind of makes our life nice and easy in terms of trying to solve an equation that has a 0 value in it, because it's usually either cancels something out or it's just whatever it's adding or subtracting with. So it makes your life a lot easier. And so with that note, do not choose your vertex because you've already put into your equation here. So I would just avoid using your vertex. So looking at our x and y axis, here, if we look at our x-axis, we'd have to round with this value right here. So maybe let's try looking at our y-axis. So if you notice here, your y-axis is at 0 and -2. That's a pretty nice value. It includes 0, makes our life a little bit easier. So let's use that to put into our equation. So we're going to use 0 and -2. So plug that into your equation. We had y is equal to, so that'd be -2 is equal to a times, so it was x minus 2, so it'll be 0 minus 2 squared, and then subtract 3. So using BEDMAS, let's first simplify our brackets here. So we have -2 is equal to a times -2 squared minus 3. Then our next step is let's actually, if we're following along with BEDMAS, let's do our exponents. So let's actually apply that square to that -2. So we have -2 is equal to, so it'd be a times -2 squared is +4, and then subtract 3. Then what we can do is we can start moving stuff across. So we'll start to actually get a by itself. And in terms of doing the adding, subtracting, multiplying, dividing, you always do what's farthest away from your variable, or you kind of almost want to go with opposite BEDMAS. So you want to deal with that adding and subtracting first. So you want to get rid of this -3, and to do that you do your opposite operations. So if this is subtracting, you want to add 3. So add 3 to each side. And what we should have is that we get 1 is equal to a times 4. If you guys put that into proper mathematical, notation, you might want to write 4 times a. We just typically write the number in front of the letter. But since we're solving for a, it's not super important because we're going to move it over anyways. So here we have a times 4, and we want to get a by itself. So you want, if this is multiplying, you want to divide. So divide 4 on each side and then just simplify. So you're left with 1/4 is equal to, this would be a times 1, which is just a. So once when you found that a value, now we're going to go back to that general function equation that we gave that has that p and q value, and then we'll just fill in our a value. So in our equation we had y is equal to, so it was a, which is 1/4, times x minus 2 squared minus 3. And that there is the vertex form of a quadratic function. Okay? And that concludes this example. So thank you guys so much for watching. If you guys have any questions, just make sure to come see me in class or text me on Remind 101.